This is a really quick example because we're basically making use of the distributive rule for the dot product. Now the distributive rule for dot product tells us that the dot product occurs across a bracket just like normal multiplication. Okay, so we expand and end up with like a dot b, a dot c, etc. So think of it really as just like a multiplication. So if we have a look here at the first question, it says A, simplify the following, a dot b plus c minus b dot a take away c. So we keep them as dot products, so this would be a dot b plus a dot c minus, and this is b dot a, and here we've got two minuses, so that will be a plus b dot c. Now what we have to understand here with dot product is the equivalence of dot product in terms of its order. So remember a dot b equals b dot a. It's commutative, so it doesn't matter what order you do that operation in, it is the same. So that means that we then have a dot b, and I shouldn't really use an equals there, a dot b plus a dot c. This is actually now, instead of b dot a, I'm just going to write it as a dot b, because that's what that is, and we've got b dot c. So you can see here now that we've got a cancellation, positive a dot b minus a dot b. So our answer is going to be a dot c plus b dot c. So therefore, to finish it off, it's a nice idea to just write out again what you had, which was a dot b plus c minus b dot a minus c, which equals a dot c plus b dot c. And that's all we need to do. For the next two, we're expanding. So again, similar kind of thing, a plus b dot a plus b, and this is just like, think of this as a multiply again. So we're going to multiply across the bracket. I'll do this in a different colour so you can see it. So across the bracket that way, so we'd have a dot a, and then we'd have plus a dot b, okay, and then in a different colour, okay, we'd then have plus b dot a, and then plus b dot b. Now a couple of things to remember from the work earlier on in this chapter. Remember that a dot a is the magnitude of a squared, okay, so we can simplify to that, and also b dot b, magnitude of b squared, and the other thing here of course is that a dot b is equal to b dot a. So we can then finish this off with a dot a, we'll write it as magnitude of a squared plus two lots of a dot b plus another b dot b, which you could write as magnitude of b squared. Now I can see that in the notes they've kept that in the form a dot a, b dot b. Both of them are correct, so I'll just put the other version there, just leaving the a dot a and the b dot b. Okay, to finish off, if we look at the last one, which I'll just delete this section here, and we're looking at b, this was part 1. Part 2 for b is a plus b, dot product with a minus b, and again we're just going to expand across that bracket, so we have a dot a minus a dot b, and you can probably see what's going to happen here, plus b dot a minus b dot b, and again we know that the dot product is commutative, that is the order doesn't matter, so I'm just going to write this as a dot b, and so you can now see that you've got some cancellations, the a dot b's cancel, so you end up with a dot a minus b dot b. So that's all we're doing here with simplifying, just understanding this key rule with the dot product, which that it is distributive over brackets, so it goes across the brackets just like a multiply does.